Hello friends, welcome again. Today we'll be solving a question related to induction motor. And the question is, induction motor has uh, stator copper losses equal to the sum of mechanical plus iron losses, okay? And its rotor copper losses are 1/3 of the stator copper losses, and its efficiency is given to us as 79%. Then he's asking us to find at what slip this is possible, okay? And he's asking us to assume that mechanical losses are equal to iron losses, okay? So how to proceed? So we know that efficiency is output over input, and it can be written as input minus losses over input, okay? And the losses here are stator copper losses plus iron losses plus rotor copper losses and mechanical losses, okay? So these are the losses, okay? Now what we can do here is we can assume that the mechanical losses are x watts, okay? So we are assuming our mechanical losses as x watts, okay? So our iron losses are also x watt. Why? Because he is saying that mechanical losses are equal to iron losses. We have to assume this, okay? So these two are now equal, okay? So if mechanical losses are x watts, so our iron losses also are x watts. Now stator copper losses, as you know that the stator copper losses is sum of mechanical losses plus iron losses, so that is x plus x, which is 2x, okay? So we write it as 2x. Also the rotor copper losses are 1/3 of the stator losses. So already stator copper losses are 2x, so 1/3 of 2x is 2x by 3 watts, okay? So this is what we have now, okay? And let's assume y watts is input power, okay? Input power. Now our what is our aim here? Our aim is to just find the relation between x and y, okay? So let us use efficiency here now. Efficiency is 0.79, okay, which will be equal to input minus losses over input, okay? So our input is y watts minus our losses are stator copper losses, which is 2x, minus our stator iron losses, which is x watts, and after that our copper losses of the rotor, which is 2x by 3, minus x, which is the mechanical losses, okay, divided by the input is y watts, okay? Now if you calculate this, okay, so what is our equation for calculation? It is 0.79 is equal to y minus 14 x by 3, okay, over y, okay? So if you calculate from here that relation between y and x, what we get is x is equal to 9 by 200 of y, okay? So this is our relation between x and y, okay? Now we have got a relation between x and y, so let us write it down again. X is equal to 9 by 200 into y. Now what we can do is we can write what is our air gap power, okay? Because if you calculate air gap power, then s times our air gap power is the uh, rotor copper losses, okay? So what we can do is we can write what is our air gap power is the input power, okay, input power, which is y, minus the stator copper losses, which is 2x, okay, as we calculated earlier, and our uh, iron losses, okay, iron losses. So our iron losses are again x watts, so we get our air gap power as y minus 3x. Now from here what you can do is, you know that your air gap power into slip, okay, which is slip times air gap power, it is equal to the rotor copper losses, okay, copper losses. So this is a very useful formula, okay? You can remember it and you can use it elsewhere also. So what you can do is air gap power, now you have air gap power as y minus 3x, and this is equal to y minus 3x if you do s times, means the slip times this power, okay, the slip at which it is operating, the motor is operating. Then what you get is your rotor losses. So rotor copper losses earlier we calculated were 2x by 3, okay? So now what you can do is you can simply put the value of x in terms of y. Okay, so what you get is s dot y minus 3 into 9 by 200 y equals to 2 into 9 by 200 into y. Okay, if you see y is common everywhere, so you can cancel it out. Okay, now we have got rid of y. Okay, now what we are left with is s is equal to, okay, 6 by 173. Okay, if you calculate this, you will get 6 by 173, which comes out to be 0.034. Okay, so this is the slip which should be there, and this matches with option B. Okay, so B is a correct option for this question. Okay, so this is how you need to proceed for the problems where there are no numerical values given. You can assume one of the values and you can proceed after that. Okay, so thanks for watching.